As we're finding x-intercepts, that was when we were solving this quadratic equation set equal to 0. If something cannot factor, then we can always use the quadratic formula. There are some other ways that you can solve a quadratic equation, like completing the square, but the quadratic formula is a very common method. The quadratic formula is this big formula shown here. So it says x equals negative b plus or minus the square root of b squared minus 4ac. That whole thing is over 2a. So this is one that you're just going to kind of have to memorize. There are other like mnemonic devices or songs that help people memorize this formula, but regardless, you will need to have that memorized. If we're working out the quadratic formula to solve the x-intercepts for this first example here in A, we have 3x squared minus 8x plus 4. A is 3, B is negative 8, and C is 4. So ax squared, bx, and c. We're going to set this up and say x equals negative b, in this case negative 8, plus or minus the square root of b squared, so negative 8 squared, minus 4 times a times c. And the whole thing's over 2a. We're going to simplify this a little bit at a time. You don't want to try to do too much at once, but negative 8 is just a positive 8. Plus or minus the square root of something, whatever goes inside that square root, we're going to simplify that here in a minute, over 6, because 2 times 3 is 6. So let's figure out what goes underneath that radical. We'd have negative 8 squared, which is important to put that in parentheses, minus 4 times 3 times 4, which is 16. So positive 8 plus or minus the square root of 16, the whole thing's over 6. Well, luckily, the square root of 16 is nice. So we have 8 plus or minus 4 over 6. That does give us two values because we have a plus and a minus. So I'm going to just work this over here because I'm running out of room. But this would say x equals 8 plus 4 divided by 6. That's 12 divided by 6, so 2. And then we have 8 minus 4 divided by 6, which is 4/6, and that reduces to 2/3. So there are two solutions for when this function's equal to 0. These are the x-intercepts. Since they are x-intercepts, we need to write them as coordinates because that's where it crosses the x-axis. So one's going to happen at 2, 0, and the other one's going to happen at 2/3, 0. They're not always nice coordinates, but this second example, in part B, we have 11x squared plus 12x minus 4 as our function. If I use the quadratic formula to find those, negative b would be negative 12 plus or minus the square root of 12 squared b squared minus 4ac, so minus 4 times 11 times negative 4. And the entire thing is over 2a, so 2 times 11. Simplify just a little bit at a time, so negative 12 plus or minus the square root of something over 22. And let's see what goes inside that radical. So I've got 12 squared minus 4 times 11 times negative 4 is 320. So we need a way to reduce this radical. And we've had a previous lesson on simplifying radicals. If this is something that you need more assistance on, that's fine. You have some extra videos that are posted to help simplify a radical. But if you have this calculator, when you do the square root of 320, it will help automatically reduce and simplify that radical to 8 square roots of 5. So I'm just going to substitute that in its spot. So the square root of 320 was equivalent to 8 square roots of 5 over 22. But this fraction is not completely reduced, so we would want to reduce this as well. I know it's not going to be a pretty answer because we have this irrational value, the square root of 5 in it. And so if this was a word problem, we could put this in our calculator and get like a decimal equivalent or approximation. But for problems that have no context, we need to simplify this fraction as much as possible. I'm going to look at the numerator and the denominator to see if there's a common factor to reduce. And 22 is even. As I look across the numerator, I have 12 and 8 square roots of 5. That is going to be reducible. And I'm going to pull out a 2 in the numerator. You'll see here in a second why. So if I divide negative 12 by 2, I get negative 6. If I divided 8 square roots of 5 divided by 2, I get 4 square roots of 5. So the numerator is equivalent to saying 2 times negative 6 plus or minus 4 square roots of 5. And that whole thing's over 22. Now I have something that's reducible because 2 22nds, 2 over 22, can reduce to 1 over 11. So our x-intercepts happen at negative 6 plus or minus 4 square roots of 5 over 11. These have some decimal values if you need to get the decimal approximations, but we're going to list out the actual coordinates, and yes, they happen to be ugly. One of them is at negative 6 plus 4 square roots of 5 over 11, comma 0. That's one coordinate. It's what the value of x when y is 0. But we had another one, negative 6 minus 4 square roots of 5 over 11, comma 0. Those two coordinates are when the function would cross the x-axis. Now, if you needed a decimal answer for this, you're just going to put this in your calculator, negative 6 plus 4 square roots of 5. The whole thing's divided by 11. This calculator will automatically just rewrite it in a fraction form, but I can use the decimal approximation to get approximately 0.268. And you can do the same with subtraction there and get a different decimal. In C, we're going to do this one more time. We have negative 3x squared plus 4x plus 3. So A is negative 3, B is 4, and C is 3. So x equals negative b, and that'd be negative 4, plus or minus the square root of b squared, that's 4 squared, minus 4a, negative 3, times c, positive 3, all over 2a. So 2 times negative 3. We're going to simplify a little bit at a time. So I end up with negative 4 plus or minus the square root of something divided by negative 6. And let's see what goes underneath that radical. That's 4 squared minus 4 times negative 3 times positive 3, which is 52. So if the square root of 52 can reduce, we will. This does. It becomes 2 square roots of 13. Again, if you don't have a calculator that will automatically do that for you, most don't, you will need to simplify that radical by hand. Go watch the video if you need to. Some extra resources on that. There are problems in the lab manual for those prerequisite skills of simplifying the radicals. So I'm going to rewrite this now as negative 4 plus or minus 2 square roots of 13 over negative 6. This still can reduce. It's a lot of work, but you do need to reduce as much as possible. So when I look across the numerator and the denominator, I'm looking for a common factor that will help reduce this. And this can reduce by a factor of 2. I'm going to pull out a 2. This was a 2 times -2 plus or minus 1 square root of 13 on top, and it's all over -6. By pulling out the 2 on top, I can reduce the fraction 2 over -6 to 1 over -3. So this would end up being -2 plus or minus the square root of 13 over -3. You often don't see that as the actual value. You would see that simplified even more to a positive 2 plus or minus the square root of 13 over positive 3. That's because they don't really like negatives in the denominator. So if I'd multiplied the numerator and denominator by -1, it would get rid of that negative in the denominator. I'm going to show you that here off to the side. So -2 plus or minus the square root of 13 over -3. If I multiply the top by -1 and the bottom by -1, this is -1 times -2, which is positive 2. A -1 times a positive square root of 3 is just going to be negative. But a -1 times a negative square root of 13 is a positive. So it still is going to say plus or minus the square root of 13. Then we have -1 times -3, which is positive 3. So that's how we got 2 plus or minus the square root of 13 over 3. These would often be listed as the x-intercepts, but we want to write them as coordinates because they are where it crosses the x-axis. So this would have a coordinate that's 1 is 2 plus the square root of 13 over 3, comma 0. And the other one is 2 minus the square root of 13 over 3, comma 0. The quadratic formula gets tricky because of having to reduce the radicals and reduce the fractions. So being able to do operations with radicals is really helpful. If you need extra practice on those, there is a prerequisite page for operations with radicals.